Archimedes, the mind that measured the world. Among the great figures of ancient science, few names carry the same intellectual weight as Archimedes. Living in the 3rd century BCE, Archimedes was not merely a mathematician or an inventor, he was a thinker whose ideas reshaped humanity's understanding of nature itself. In an age without modern laboratories, digital tools, or even formal scientific notation, he managed to unlock principles that still underpin physics, engineering, and mathematics today. Archimedes was born in the city of Syracuse, then a powerful Greek city-state. He spent much of his life there, although historical accounts suggest he studied in Alexandria, the intellectual center of the ancient world. Unlike many philosophers of his time, Archimedes was less interested in abstract debate and more concerned with measurable reality. He asked how things floated, how levers worked, how shapes could be calculated, and he insisted on precise answers. Perhaps the most famous story associated with Archimedes is the legendary Eureka moment. According to later writers, he was asked to determine whether a king's crown was made of pure gold without damaging it. While bathing, he noticed that water overflowed as he entered the tub and realized that volume could be measured through displacement. This insight led him to formulate what we now call Archimedes' principle. An object immersed in a fluid experiences an upward force equal to the weight of the fluid it displaces. Whether the bathhouse story is entirely true or partly myth, the principle itself is undeniably real, and essential to shipbuilding, engineering, and fluid mechanics even today. Yet Archimedes' contributions went far beyond buoyancy. In mathematics, he calculated the value of pi with astonishing accuracy using geometric methods, centuries before calculus was developed. He also determined formulas for the area and volume of shapes such as spheres, cylinders, and cones. In fact, Archimedes reportedly considered his work on the sphere his greatest achievement, requesting that a sphere and cylinder be engraved on his tomb. Archimedes was also a practical inventor, especially when Syracuse faced military threats from Rome. Ancient historians describe war machines designed under his guidance: giant levers, grappling hooks, and mirrors said to focus sunlight onto enemy ships. While some of these accounts may be exaggerated, they reflect a deeper truth. Archimedes understood how abstract principles could be transformed into real-world power. His famous statement, "Give me a place to stand, and I will move the earth," was not mere arrogance but a poetic expression of mechanical advantage. Despite his brilliance, Archimedes was known for his disregard for wealth and status. He lived simply, often becoming so absorbed in his work that he forgot to eat or bathe. This image of the absent-minded genius, lost in thought, has followed scientists ever since. Tragically, Archimedes died during the Roman capture of Syracuse, reportedly killed by a soldier while absorbed in a mathematical problem. The story, whether literal or symbolic, highlights a life devoted entirely to knowledge. What makes Archimedes especially relevant today is his method. He insisted on logical proof, careful observation, and mathematical precision. Long before the modern scientific method was formally described, he was already practicing it. Later scientists, from Galileo to Newton, openly acknowledged their debt to his work. In many ways, Archimedes feels like a figure out of time. His curiosity resembles that of a modern physicist, his inventions anticipate industrial engineering, his passion mirrors that of today's researchers working late into the night. Yet he achieved all this with tools no more advanced than straightedges, compasses, and an extraordinary mind. Archimedes reminds us that progress does not always depend on technology. Sometimes, it depends on the courage to ask simple questions, and the patience to pursue exact answers. More than 2,000 years later, the world is still standing on the foundations he laid.